All right, we are recording. Now we are going to do inequalities in slope-intercept form. So the focus is going to be inequalities written with a y variable are shaded above and below. How do you shade if only one variable is x and the line is vertical? Well, that's a good question. So here below we have an equation. The solid line is given to you. Change the equation to an inequality according to the shading. So if you look, right, here's your equation, and here's your inequality, okay? So again, for A, why did we shade above? Well, it's greater than. But if we were to test the point, remember what I told you before, if I test 0, 0 in here, because I got both variables, I can test it. I would get 0 is greater than or equal to 1. Is that a true statement? Nope, that's false. So I would shade opposite the 0, 0 side, which is up here. So instead of trying to remember that, is it equal to, is it bigger, is it less? You know all the points that go this way are less, but I kind of like using one point as kind of a check solution. Okay? Now, if you have y equals negative 3, we are going to make this greater than or equal to negative 3. Okay? Now, I can't use 0, 0, but I could plug in 0, right? Because there it is, y is 0. And if I plug in 0, is 0 greater than or equal to negative 3? That's what you got to ask yourself. And yes, it is. So that is why all this is shaded. Okay? And then same thing here. X is greater than or equal to negative 2. Notice how all the points, remember on the x-axis, if it goes this way, it's bigger. If it goes this way, it's less. Same thing on the y. If it goes this way, it's negative. That way, it's positive. So we're shading all the points greater than negative 2. And again, if you plug the 0 into there, there's the 0. That's a true statement also. So again, those are just ways that can help you kind of see the shading. All right. So it says, is the point 0, 0 part of the solution set for inequality A? No, it's not. And I just kind of showed that to you, right? It's not in the shaded region. So again, how can you tell if 0, 0 is part of the solution set for the inequality? Well, remember, if you plug in 0, 0, a 0 for y and a 0 for x, to the inequality, and it makes it a true statement, then it's a solution. And that's the side where you would shade. Okay? And then same thing here. How can you tell if the 0, 0 is part of the solution set for inequality A? From the symbols. Well, you see the line there, right? And when I plug 0, 0 in, just to the inequality itself, forget the line. Okay, the graph, you can visibly see it, right? For the equation, you just visibly check it. If I check it and I plug a 0 in for here, and this is 3/2 times 0 plus 1, I get this. If that's a true statement, it's a solution. This was not a true statement because we plugged it in, so it's not. So again, it's a great test point because it's usually, the only line obviously you can't test it for is a line that goes to the origin. Then you just got to pick a different point. So I kind of moved this, so let me just kind of back up here. So this answer actually goes down here. And then when you actually look at the graph, you would just make sure the points, you'd look for the point in the shaded region. That's more of a visual thing, right? So then down below, what patterns or relationships do you notice? Is that any point, because they're equal to, so all points on the line and in the shaded region make the inequality true. Okay, moving on. We got a few pages here today. There's 4 of them. We should get through it rather easily. All right, so it says trace the dashed line with a color. Okay. So I'll make it, since it's black there, I will make this red. We'll humor it. Okay, there it is. Write the equation of the dashed line. Well, this line is going through the origin, and if I figure out the slope from the origin, if I go up, I can go up 2, it looks like it goes right here, over 1. So our slope is 2, so 2x. The y-intercept is the origin, so I don't need to write a plus 0. We're good there, okay? If I make it an inequality, all right, now it says shade the side of the line where the star, with the color, with the star. So the star is to the right here. So this is where we're shading, right? Which means all the solutions to this would be over here. So we would have to write an inequality, change the equation to an appropriate inequality. All right? So again, this goes through the origin, right? I can't test it. So we can test something else. We could test the, we could test a point either in the shaded region, because I don't know, do you know if it's greater than or less than? Since we're going to the right, it's going to be y is less than, so the 2x, when you plug points in, it's going to be greater than y. Okay, so try that. If we had the point 1, 0 is in there, right? 1, 0, I'm going to do this in black just so you can see it. So you can test it to see if you got it right, right? There's 1, 0. So that's a 1 for x and a 0 for y. Is 0 less than 2? Yes. So that way you know you picked the right inequality. If we had it going the other way, it would be saying 0 is greater than 2. Is that the case? No. So that way, that's kind of how you know you have the right inequality, is using those test points. Those test points will help. Now, we have a horizontal line. The equation of a horizontal line is y equals 1. All right, I'm not going to trace over this line anymore. That's stupid. All right. So, the point is below the line. Now remember, anytime we go above that line, we're going up, we're increasing. This is decreasing, right? So if the point is down here, and we're shading below, okay, that means all those points are less than 1. So this would have to be y is less than 1. And test 1. Throw 0 in there. Is 0 less than 1? Yep. So you know you got the right inequality. Now over here, a vertical line at 2. So x equals 2. Okay, that's the equation on the line. However, if we're going to write it as an inequality, and again, the point's on this side, so that means we're shading over here. Okay, well again, when the line goes this way, all the x values get smaller. When the line goes that way, the x coordinates get bigger. So this will be x is less than 2. And again, plug in an x point, that's to the left of the dotted line. Plug in 1 or negative 1. Those are values that are less than 2, so you know you have the right inequality because it's in the shaded side. Okay? And that's how you can check. So it says, is the point 0, 0 part of a solution set for inequality D? No, it's not, because it's on the line, and the line is dotted. If that wasn't equal to, then yes, it would be. But it's on a dotted line, which means you can't include the points on the line. So it says, how can you tell if 0, 0 is part of the solution set for inequality D? Well, you can check to see if it's in the shaded region, okay? But not, it's on a dashed line, okay? You can't tell because, again, that point is right here, and so you can't really tell if it's in the shaded region or not, okay? But since it's on the line, no, it doesn't work because it's on the line, and the line is dotted. So I kind of asked us the same question there. So in the graph, again, that's a visual. You see it's on the dotted line? No. How can you tell if it's part of the solution? Well, again, we have the equation, right? So if I plug in the zeros, is 0 less than 0? No. It's equal to, but there's no equal to. 0 is not less than itself. So that is incorrect, which is why you know 0, 0 does not work. So, what patterns here do you notice? That all points in the shaded region will make the inequality true. However, all points on the dotted line, because all these were dotted lines, right, will not make the inequality true. It's late in the day, folks. Apparently after 4 o'clock, my penmanship goes down. Okay, on to page 3. So explain why it makes sense that there is one solid line and one dashed line for the inequality that you see right here. Well, because number one, you got 2 lines, okay? So you got to think of this as breaking up into 2 spots. You got -3 is less than or equal to y, and you got y is less than 1. So this equation, okay, is right here. And this equation is right here. But we wrote it as a compound inequality, okay? So it's basically everything less than 1, which you can't be included because here, this is a dotted line, so you can't include points in the line. But here, since that's a solid line, you can include points on that line, the solid line. So it's basically anything greater than -3, which includes the lines on -3 points, but you can't touch 1. So it's any decimal or any up to, but not including 1. Okay, and I know I made an equal sign there. That should not be. There we go. This should be. It doesn't include it. Okay. So why does the shading make sense? Well, any part where the y is greater than or equal to -3, is that's above it. Okay, but then you also have the compound of y is less than 1, and that has to be below it. So it kind of makes it a sandwich, so to speak. The 2 lines are the bread, and the shaded area is your stuff inside the sandwich. Whether you're a meat and veggies person that puts like a ham, lettuce, and tomato kind of person, or if you're a PB&J, but think of it as a sandwich. Okay, so it says the point 2, 1 is not part of the solution for this compound inequality, but 2, -3 is. What's the difference? Well, we'll use the red marker for this. So at 2, 1, okay, Why doesn't that work? Because this is a point on the dotted line. And of course, well, you know what? Recording in YouTube was great for a while because the board wasn't messing up. Now it's messing up. Okay, on the dotted line. Because you can't include points on the dotted line. But the coordinate 2, -3 happens to be on a solid line. And again, because that's the greater than equal to. And again, since it's solid, it will include the points on that line. So that's why this is a solution. However, that is not. Okay, it all depends on where things fall on the dotted line. So let's try one. All right, so we got 0 is less than x, which is less than or equal to -2. So think about it. We break it up, right? 0 is less than x, okay? So this happens to be a dotted line on the y-axis, because the y-axis have all the x points. So I am going to draw a dotted line. And it's probably not a very good dotted line. Let's make this a little bit better looking. How's that? We're going to shrink this, and we're going to make our dotted line. And we're going to make it red. Dashed. And we're going to go right up here. And I'm going to drag it right over the x-axis. There we go, right there, right over the y-axis. So that was our first part. And then we got our second part of x is less than or equal to 2. Now, this is going to be a solid line. We'll make it blue. And that's going up 2, so which is right here. Okay, there we go. So that means all the points less than 2, but including, so it's kind of shading in here, right? But all the points greater than 0. So our shaded region is everything inside these two lines. It can touch the blue line, but it cannot touch the red. Okay? So you can't include points on the red line. So anything that's 0 can't be included. Okay? So it says identify a point that is on the border of the solution region that is not part of the solution. 0, 1, 0, 2, 0, 3. Those are all points that are going not a solution. But 2, 1, 2, 2, 2, 3 are, because that line is solid. And anything in between in this shaded region will be an answer for this. Okay? All right, so down below, a little summary here. So it says, how do you graph the following inequalities? So when you have something like this, okay, this is going to be a dashed or a dotted line. It's less than, so it's going to be shaded below. When you got the less than or equal to this one, this is a solid line. Shaded below. And then when you go to the greater than, or y is greater than, again, you got another dotted line here because it's not equal to. And this is going to be shaded above. And again, if you don't remember that, use test points. And then over here, you got a solid line. Also shaded above. So you can see the difference between them. So it says here, how would you shade if only the variable is x and the line is vertical? Okay, so x is less than whatever, c is some number. Okay, so if x is less than that, you would well, first of all, you know the line is dotted. But since it's less than, it's on the x-axis, that means that you're shaded left of the line. So if x was 2, you'd be shaded to the left of 2. If x was -1, you'd be shaded to the left of -1. Okay? So again, c is basically just kind of some integer. Okay? Now, if it's equal to, All right, this is solid. It's a solid line, but it's still going. It's still less than, so you're still shaded left. But again, over here, all the points in that line aren't included. Where over here, all the points on the line are included. And then over here, this will be a dotted line. But now you're talking about greater than. So if we made this a 2, that means any point greater than 2, this is shaded to the right. And this would be a solid line shaded to the right. And in the third one here, this would not include the line. This would include the dots on the line. So it says, how can you tell if a point is part of a solution region? So it's either in the shaded region, the point falls in the shaded region, or it's on a solid line. Has to be solid. So let's do a couple examples to kind of explain what all this stuff means. All right? Checking for understanding. So here we are given an equation. Y is greater than negative 4x minus 1. So if I go ahead and graph the points, right? Here's it at 1. I'm going to shrink this because I'm going to make my line feature here. And then I'm going to go down 4, 1, 2, 3, 4, and over 1. So there's my other point, right? There's no equal to, so it's a dashed line. And we'll see if I can get this to go through the points. Yeah, that's not bad. All right, we'll make this line, we'll make it red. Now we'll just keep it blue. Okay. So there we are. So there is our line. Okay? Now, is 0, 0 a solution or not? So let's test it because we're going to see where we're going to shade. Now, if you remember from the notes, okay, anything that is greater than is shaded above. But again, if you're not sure, test it. 0, 0 is right here, which means it's to the left of the line, right? So if I plug a 0 in for y and a 0 in for x, negative 4 times 0 is 0. Is 0 greater than 1? No. Which means the side of the line where 0, 0 is not a solution, which means your points have to be all over here. And they will not include the line because it's dashed. Now, if we graph the next one, y is less than or equal to negative 4. So this is a solid line at negative 4, which is right here. I'm going to bring it up just a little bit. I went a little too low. Right here, okay? And is 0, 0 an answer? Well, I can only put in for y. So is 0 less than or equal to negative 4? Nope. Which means we have to shade below. Because it is not. Okay? Now, down for number 3. Okay? This is a dotted line that goes through the origin. So make it a dotted line. We'll make this one blue. And we're just going to go straight up through there. Now, I can't test 0, 0, but I can answer this, right? Because 0, 0 is on the line, and it's dotted. No, we can't. So let's test a point that's not on the line. All right? How about this point right here, which is 1, 0. 0 for y, 1 for x. So if I plug in a 0 for y and a 1 for x, is 0 less than 1? It sure is. So you would know that this part of the line, this side of the line, is shaded. If you can't remember your rules about shading above or below. Look at that. So far, so good. And then the last one is we have a compound inequality. So this would be like saying negative 4 is less than x. So that line would look something like this. We got two lines here. So at -4, there we go. We'll move that over a little bit. There we go. And then our other line, we'll make blue, is at -1, which is right here. Okay? So there's our two lines. Okay? So again, if I were to plug a 0 in here, okay, 0 is greater than -4, right? So where the red line is, I'm going to shade to the left of that, okay? I'm going to shade to the left of it. And technically, if this blue line wasn't here, we would be shading all this area, okay? So that would kind of give you a better understanding, right? That would be this, right? However, is 0 less than -1? No, it's not. So that means from the blue line, we'd be shading everything over here. So our solution, if you look, is where the answers kind of, the two colors kind of overlap, right here. And this would be our solution, is everything in between the lines. But since they're both not equal to, it's nothing on the line. Nothing on the line can be an example. So is 0, 0 a solution? No, it is not. All right, and that is the notes for slope-intercept inequality.